Hi everyone. Today we're going to take a look at variance and standard deviation. So with a small set of numbers, I'll work through this just so that you can see it by hand. A lot of times we will use software to do this, and I'll show that next. But here, let's take a small set of numbers, 3, 5, 7, 9. All right. When we talk about variance, we typically use the notation s squared. Variance is really the average of the distances from the mean squared. So that's a mouthful. Basically, what we end up having to do is say, okay, let me first find the average of these numbers. So 3, 5, 7, and 9. Excuse me. So the average of these, x bar, is 6. So to find the variance, we usually have to take each of these x's minus x bar and then square that number. And then we add it to the next one and square it. And we keep doing that for all of the x's. All right. So basically, I'm going to take each one. I'm going to have 3 minus 6. I'm going to have 5 minus 6, 7 minus 6, and 9 minus 6. Take all of those answers, negative 1, or excuse me, negative 3, negative 1, 1, and 3, and I'm going to square them. So once I square them, I have 9, 1, 1, and 9. All right? That's doing this part of it, x minus x bar squared for each one of the x's that I have here. All right? Now, the next part in the variance is to take all of these things, and with a sample, and this is kind of strange when we find this, with a sample in statistics, we divide it by n minus 1. When we normally find the average, I'd say let's add all these things, 20, and let's divide it by 4. That's normally what we would do for the average. But in statistics, we're going to add all of them, so 20, and we're going to divide it by n minus 1. So we're going to divide this by 3, and we're going to end up with 6 2/3, or 6.66. So that ends up being the variance for this number. It's the in, I suppose, the smallest notation. I'm going to erase a couple of these things here. In the smallest way to write this notation, we take each one of the x's, so I'm going to call it xi, minus x bar, and I'm going to take those and square it. I'm going to take the sum of all of them, and I'm going to divide it by n minus 1. So this is s squared. To find the standard deviation, a lot of times standard deviation is just written like this. Standard deviation is really the square root of what we just did. So I'm actually going to come in here and copy this. Yeah, we'll take this, what I just did, and we're going to paste it on in here. I'm just going to take the square root of that. All right. This in here was s squared. If I take the square root of it, it's just s. That's the standard deviation. So in this case, I had, if I remember correctly, 6.66 was my variance. If I take the square root of that, that's going to be my standard deviation. And I'll pause it for a second. I got to see where my calculator's at. So the square root of this ends up being 2.58. So that's our standard deviation. So taking that idea, I'm going to do the same thing with a set of data that I have already in Excel, or in this case it's in Google Sheets. So let's jump over to Google Sheets. So here's the data that I have, and I'm going to build this formula from scratch in here because I want you to see a few of the tricks that you can do when you're working with Excel or Google Sheets. So remember, the first thing I want to do, and I'm actually going to insert a row up here so that I can basically say what I'm doing here. First, I'm going to find the average. of all of the data. Then I'm going to subtract each number minus the average. Then I'm going to square all of that. And then I'm going to the sum of all of this. And then I'm going to divide it by n minus 1. So those were kind of the steps that I had taken before when I was working through it. But I can do that really nicely with a larger set of data by following a couple of tricks here. So the first one, I'm just going to do the average. I'm just going to use the average formula. There's actually a standard deviation formula, but I'm just finding the average of that set of numbers. So it's 40.77. Okay. I'm going to round this off, so it's a little bit off. I could use that data, but that'll make one of these steps a little bit more complicated. I'll show that later. What I want to do is I want each one of these numbers minus 40.77. So to do that, I'm going to start a formula that says equals, but instead of just typing 1, I'm going to click on the 1 over here. So it says equals A2, whatever's in the A2, minus 40.77. Like I said, I'll round it 40.778. All right, and hit enter. So it subtracted 1 minus 40.778. So the reason I did it like that by clicking on A2 is this way I don't have to type this formula again. I can click on this, and in the bottom corner it's got this little square that lets me copy the function. And what you're going to notice is that each one of these, if I look up in the corner, this one was A2 minus 40.78, this one was A3. It basically recognizes like a positional relationship. It says, I want to subtract the number that was 2 away minus 40.778. All right, and I hard coded in the 40.778. So now I have all of my x minus the averages. I'm going to do the same thing when I want to square it. I'm going to hit equals. I'm going to click the cell next to me, and if you remember with a calculator or in a computer, the caret that's above the 6 squared, and it squares that number. Again, I'm going to, instead of typing all those up, I'm just going to drag this formula down, and it will take the number next to it and square it. To do the sum, we've done this, I just used the sum formula equals the sum of all of this data. All right. I'm going to do one other one in here just to show you something. So I'm going to insert a row here, one to the left. I'm going to do a count. All right. How many? That's the number of n. So the count ends up being, you know, looking at this, I know there's 9 numbers. I'm going to do equals count. And it basically is just going to count how many numbers there are. And it says 9. All right. So the reason I did that is so in this last one, I can divide this one divided by, and I'm going to put this in parentheses, 9 minus 1. You know, basically I do the count, so I could have just said equals 14,805 minus or divided by 8. Because remember, we're dividing it by n minus 1 when we're doing variance in statistics. So this is my variance. All right, this is the average of the squares of each x minus the average. Mouthful. So this, what I just found right here, was the variance, which a lot of times we write as s squared. Now I'm going to find the standard deviation, which is usually just s. To do that, I simply take the square root of this number. So the standard deviation is 43.02 if I rounded that off. All right. But again, the real trick with this is recognizing the way that you can build this formula. And what I wanted to show you was the way that you copy each of those things whenever you wanted to make a formula. So just as an addition to that, if I wanted to do this without putting them in, like instead of saying A2 minus 40.778, I can say equals A2 minus B2 but that formula is going to change when I drag it down. It's always going to do A2 minus, in this case it does minus B3, and A4 minus B4. If I want to lock the B2 in here, I change that formula by putting in a $ in front of the B. It locks in row B, and it locks in row 2, or column B and row 2. $signs in there locks that in. Still gives me the same one for that top one, but now when I drag it down, you'll notice this formula does not change the B2 in each one of those. So kind of a little trick in there, and you should notice that when I change these numbers, I've got this formula built that it's going to change all the others. If I throw in a 54 over here, all of my numbers change because it changed the average, it changed this row, everything changed because the formula was built on the data that's in there. So that's basically how you can throw that together or build the standard deviation formula in Excel.